Hi guys, so today we're going to be going over Hibbler Statics question 275. So the goal is to find the magnitude of F3 and the coordinate direction angles alpha, beta, and gamma. So let's get right into it. Let's solve for our F2 and F1 Cartesian coordinates. So here, this is simply going to be zx because it is in the zx plane. So what we want to do is, sorry, I thought I had that on. This is zx, and then we go and make our triangle. We go 5, 12, 13. I like to do this because I feel like it's easier to visualize. This is in the zx plane, you see, bang, 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 right? You see that? And, you know, see your parallelogram or whatever, right? Anyways, that's that. And now F1, as you can see, is in the zy plane. So let's draw this out as well. So we go z, and then we go y. Z, y, we draw our triangle, and we write our direction angle, which is 30 degrees. And from there, we can solve. This is really all we need other than these two. Obviously, you have these we need, and we need this. And from this, and then this formula here, we can solve. So we'll go to the next page and write out our Cartesian coordinates. Okay, so from here, let's start with F1. So we go F1 is going to be, it's going to be 0 in the x direction, so 0, I. And then it will be a negative z and a positive y. So we're going to add our y. And our y is simply, as we know, it's just, this is z, and this is y. So y, z, and then, you know, you have 30, you know, right? And you just want to go bang, bang, right? And this is also 30, so opposite is z, you know what I mean? And so sine, and let's get right into it. You have your 30-degree direction angle and 12 kilonewtons. So we just want to go 12 cosine 30 for y. Cos 30. And then we subtract because z is going in the negative direction, and it will be 12 sine 30. 12 sine 30, just like that. And there we go. I will write the Cartesian coordinates in. Sorry about that. And boom. And now we'll do our F2. So again, we are going to draw our little chart like that. And this is in the z, the xz plane. Xz. Just like that, because we can see this is the z plane and this is the x plane, just like that. And then, so what we want to do is we want to draw our triangle, and it already gives us the numbers, so we don't need to mess around with any angles, just like that. And we know it's 10 as the magnitude. So now what we want to do is we go and we draw it out. So we know that j is 0, or, you know, so we go plus 0j. Just get that out of the way. And then now what we want to do is we want to find our x and our z, or k. So now in order to find our x, we want to do, we want to work with the angle. So when you're plugging these numbers in here, you want to kind of place them as if it is, you are going to put the number you want to find on top over the hypotenuse, or the number where your magnitude is. So here it would be for z, it would be 5 over 13, 10 and 5 over 13. And for x, it will be 10 and 12 over 13, like that, if you guys can see. And now, so we just solved them. So obviously, we're trying to find x, so we go 12 over 13. This is where our magnitude is. This is what we're trying to find. So we go, and that is going in the negative x direction. Keep that in mind. So it will be negative 10 and 12 over 13. Just like that. And the z is positive, so we go add 10, and it will be 5 over 13. Yes. Just like that. And f3 is yet to be found. So there it is. And now we want to find the magnitude of f3. So first we have to find the x, y, and z, or I, j, k of that. So what we want to do is we just go f3x equals f3y equals f3k equals. So now what we want to do here is we have 0 in f1, so it'll just be 0i plus, this is for f1, and then obviously we have minus 10 and 12 over 13 there, like that, in the I for f2, and obviously we're going to add our f3x I, and we're going to set it equal to 0. And also, if you aren't looking at the textbook for this question, the resultant magnitude here is 9 kilonewtons, right there. So there we go, and if we solve for this here, it will simply be, if I'm not mistaken, it should be f3x equals 9 point, let's just see, so 10 and 12 over 13 is going to be 9.23 kilonewtons. And then f3y, we're going to do the same thing, except we're going to set it equal to 9 because the resultant is 9. And if we use our formula from before, it's going to be there, so it's going to be 9 minus that, right? So 9 equals, we have our y right here, so it's going to be 0 in f2, so we can leave that out. And we're going to add f3yj to this. And then the only thing we're working with here is our j right here, or our j up here. It's hard to read my own writing even sometimes. Yeah. So we have 12 cos 30 there. 12 cos 30. Sorry for the messy writing. Just like that. And then we have f3k here, which we just add our k's up, so it's going to be negative 12 sine 30 in f1 and 10 and 5 over 13 in f2. So should just be f3x plus, and obviously we've set the z or k and also the x or I to 0 because the final magnitude is only in the y direction. That's why we used it here. And sorry, this will equal negative 1.4 kilonewton. And then we add 10 and 5 over 15, 13. And then we subtract 12 and sine 30. 12 sine 30, just like that. And what we want to do here now is solve for our f3k. So we go f3k equals should be 2.15, because if you put in your calculator, we are going to bring them over. So these equal 0. If you bring this over, this goes positive. 12 sine 30 is 6. If you subtract 10 and 5 over 13, which should be 3 something, you're going to get 2.15 kilonewtons decay direction. So now we have all our F3 components. We can find our resultant, and from our resultant and these components, we can find alpha, beta, and gamma for F3. So let's go to a nice clean page for this. So now F3 X equals 9.23 kilonewton. F3Y equals negative 1.4 kilonewton. And F3K equals 2.15 kilonewtons. Now, if we want to solve for our magnitude, we are going to want to add these together, square them, and then square root them. So, just like this. So, F3 is going to equal the square root of 9.23 squared plus negative 1.4 squared plus 2.15 squared, which means F3 is going to equal 9.58 kilonewtons. And in order to find our coordinate direction angles, we're going to use this. So it's going to be 1 angles over, like that, or equals Fy over F equals Fz over F, just like that. So now we'll just solve there. So now solve for F3 alpha. So we want to go, nice clean spot here. Let's go F3 alpha, like that. We just want to go, let's cosine inverse. And if we want to solve for this, it's going to be cosine inverse. Obviously, we're going to look for our fx, which is 9.23. And then over our magnitude, which is 9.58, which is like that. And this should get you 15.5 degrees. The messy writing there, guys. 15.5 degrees. And then now our F3 beta equals cos minus 1 over, should be inverse cosine, and it's going to be negative 1.4 over 9.58, which should equal 90 something. Let me just check for you guys. Which is 98.4 degrees. Now I'm going to find my F gamma. So obviously I'm going to do cos minus 1, or inverse, and it's simply going to be, so it's going to be K here, like that. It's going to be gamma. So I'm going to go 2.15 over 9.58, which equals 77 degrees. Let's make sure of that. Yes, it is 77 degrees. And there we have it. Our resultant and our coordinate direction angles. So F3 alpha is going to be 15.5. F3 beta is going to be 98.4 degrees. F3 gamma is going to be 77 degrees. And the resultant will be 9.58 kilonewtons. Thank you guys for watching.